Perfect. Thank you very much. All right, so good evening, everyone, and welcome to today's hands-on workshop for the Applied Business Intelligence program at WeCloudData. I'd like to thank everyone first for taking the time out of your evening to join us, and I look forward to having a great session with everyone. If you have any questions or comments, please feel free to put it forward in the chat, and I will try to get back to you as best as I can. So before we get into the project, I'll start off with a bit about myself. So my name is Adnan, and I am the program manager for the Applied Business Intelligence certificate at WeCloudData. Now, before joining WeCloudData, I've previously worked with different industries in different parts of the world. So after graduating as a software engineer, I worked for Maybank in Malaysia as a business intelligence analyst for a short period before I moved to Saudi Arabia and started working for an electrical solutions company called Advanced Energy Solutions. Now, I worked there for about 2 years before deciding to move to Canada. And after I moved here, I worked as a remote software engineer with an IT consultation company based in San Francisco, where we work mainly on client projects for analytics and websites before joining WeCloudData. So a bit about the company as well. WeCloudData is a leading data and AI training company in Canada, and we're also an accredited college known as the Toronto Institute of Data Science and Technology. Now, we've been recognized by both private and public institutions as a top choice for corporate training for employees, as well as a valuable pool of graduates to recruit from. Now, we currently offer boot camps and diploma programs in different concentrations of the data career pathway, such as business intelligence, data science, data engineering, artificial intelligence, machine learning, and DevOps. Now, here are some examples of our industry partners and clients we've worked with in the past, either from corporate training or under our consultancy program. Now, feel free to go through our website for some of the highlighted student stories, just so that you can understand what kind of journey they've gone through as they have arrived to us with a diverse set of backgrounds and now currently fully fledged data experts who will be shaping the digital landscape in the future. Okay, so let's jump right into it. Now, today's topic at hand is all about scraping financial data with Python. Now, many of you might have already heard about Python, and I'm assuming that's why you're here in this session today. But before we get started with that, let me run a quick poll, which I would like everyone to respond to. And this will give me a good understanding of what the demographic is like for the whole audience today. So on your screen, you should see a poll popping up. Okay, so that's 95% done. So I will end the poll now. And let me show the results on the screen. So now you should be able to see the results on the screen. And it looks like about half of you have already experienced Python before. At least 80% of you have experienced Python before to a certain degree. And I'm assuming that you're just looking to learn more. So I will briefly go over the basics first, and then we'll jump right into the project itself, okay? All right, now, since you've already worked with Python, all of this might already seem familiar to you, but for those who's completely new to Python, for the 20%, now Python is a high-level interpreted programming language. Now, what that means is that as contrasted with other software languages like C or C++, most of the functions are prepackaged, which you'll have to invoke with just simple commands, okay? Now, again, that might seem like gibberish to you right now, but let's take a look at it once we're going to be coding with it. Now, Python, it's widely used for web development, scientific computing, data analysis, artificial intelligence, and more. Now, the the reason why Python is so popular is because of its simple syntax and dynamic semantics that make it a great choice for beginners and experienced programmers alike. It is also open source, meaning that it is free to use and distribute. Now, there are many advantages to using Python, some of which include that it is easy to learn. Now, Python by itself has a simple and straightforward syntax, which makes it very easy to read and write. Now, this makes it a great choice for beginners who are learning to learn programming. It is also versatile. Now, Python can also be used for a wide range of tasks. As I've mentioned before, as it's used widely in web development and data analysis, it can also be used for many other tasks that are supported by the wide expanse of libraries that are out there. And I'll explain a bit more about that as well. One of the reasons why Python is also very popular is because of the large community that supports it. Now, since Python is open source, it means that anyone who knows how to work with Python or anyone who wants to work with Python is actually able to contribute to the language itself. So let's say that you are working with Python and you have an idea that you'd want to include, or you think that should be included in the core Python library, right? You could always make a suggestion on Python's GitHub page, and the people who are responsible for managing the whole package would take your point into consideration. And if they think that it's a good idea, then they would definitely include it, right? Now, with this large and active community, this also means that there is a huge wealth of resources, libraries, and support available. So regardless of which use case you're trying to solve with Python, you'd almost always find resources and support there. Now, in addition to that, you also have a lot of libraries in Python, and we're also going to be taking a look at what kind of libraries are available later. Now, Python by itself has a large number of libraries and frameworks that make it easy to perform various tasks like web scraping and machine learning, just to name a few. And that's what we'll be focusing on for today, web scraping. The other advantage of Python is that it's cross-platform, which means that Python can run on a wide range of operating systems, including Windows, Mac, and Linux, which also makes it a great choice for developing cross-platform applications. It is also high performance, which means that with the help of libraries like NumPy or Cython, Python can perform complex computations with high speed and efficiency. Okay, now you may ask, why use Python when you have other tools to work with data, right? Now, if you've been working with data to a certain degree, you might already know some of these symbols that are popping over here. So you have R, SQL, Tableau, Power BI, Excel, Oracle, Git, Shell, Scala, Spark, and spreadsheets in general. Okay. Sorry. I did not notice these messages. Are you guys able to hear me now? Okay, let me just move myself closer to the mic 1 second. Okay, is it a bit better now? All right, cool. I will try to speak up a bit as well. Okay, so getting back to the comparison of Python with other tools, okay? Now, Python by itself, since it's a general purpose language, right, you can pretty much apply to a lot of different applications, which also has other softwares in the same domain that helps you do what you will need to do, okay? So, for example, Python versus R, okay? Now, for those who are coming from a statistics background, you might already be familiar with R, but for those who are not, R is a very popular package which is used for statistical computing, okay? Now, both Python and R are they're both popular programming languages for data analysis and scientific computing. Both have similar capabilities, but there are some key differences between the two. For example, syntax. Now, Python has a simpler and more consistent syntax, which makes it easier to learn and use for beginners. R, on the other hand, has a more complex syntax, which is more specialized for statistical analysis. In terms of libraries, Python also has a wide range of libraries and frameworks for various tasks, including web scraping, machine learning, natural language processing, and the other things that I've mentioned before. R also has a more specialized set of libraries, but it only extends to statistical analysis and visualization. Now, when it comes to performance statistics, R was probably the best tool back before all the libraries came out for Python. So seeing what R is capable of, Python developers or the community of Python also decided that, like, libraries in Python should also be able to support what R can do. And this led to the innovation of NumPy, Pandas, and all the other data libraries that you might already be familiar with. And to a certain degree, what Python can do now exceeds what the capabilities of R can have, okay? Sorry, I'm also going through the chat as well, just to see if I missed any question. I do see some private messages popping up. I will get back to you as well. I also have a question. Okay, so we actually have an interesting question about ChatGPT. Let me get back to you about this at the end, okay? All right. So in summary, as compared to R, Python is a general purpose language, which has simpler syntax and a wide range of libraries, which makes a great choice for beginners and those also working with a variety of tasks. Now, if you're working only with statistical things, then R, you could always just get away with R. But then again, if you're just learning it, Python would prove to be a simpler task to learn. Okay. After that, you have Python versus Excel. Now, Excel is one of those tools that pretty much everyone's worked with if you're involved with managing data or working with data. And it is probably one of the most popular analytical softwares that are out there, even to date. Even with all the other different providers giving out different specialized softwares that does data analysis better, Excel is still at the forefront of analytical ventures of many different companies out there that are still waiting to step up their analytical game, okay? Now, how does Python and Excel compare? Well, Excel by itself is just a spreadsheet software, right? Spreadsheet softwares, they're very good at handling data, and it's mainly designed for manual data entry and manual data manipulation. In contrast to that, Python, it does not handle manual data entry as easily as Excel does, but then again, it does have other advantages over Excel. For example, the data handling capabilities. Now, because Python is open source, it's general purpose, it can handle much larger and more complex data sets than Excel. It can also handle a wide variety of data types, including text, images, and audio. Excel, on the other hand, it's primarily designed for working with numbers and tabular data only. Now, of course, like Microsoft keeps coming up with new innovations for Excel. Recently, they've added a Sparkline update, which basically allows you to do dynamic graphs in Excel itself. But then again, it cannot be compared with what Python can do. As far as automation is concerned, Python can also be used to automate repetitive tasks, such as data cleaning, data transformation, and data visualization. And on the other hand, Excel does have some automation features like macros, but it cannot be as efficient or as flexible as Python. Now, scalability is also another factor to consider between Python and Excel. Python scripts can be run on a wide range of systems, such from small laptops to large clusters. Excel, on the other hand, is limited to the resources of a single computer. So let's say that you are looking to implement distributed computing, right? Either in the cloud or on-prem servers. You could always use Python scripts and deploy it to run parallel on different systems at the same time. But on the other hand, Excel, you would have to set up each individual system to run the analysis. Moving on from that, let's take a look at what Python does compared to visualization softwares like Power BI or Tableau. Now, Python, being the general purpose language as it is, it can also support visualization. On the other hand, you have softwares like Tableau or Power BI, which are specialized visualization softwares. Okay. Now, again, Python's general purpose feature allows it to be good at everything, but not the best at one thing, right? And as Elizabeth is saying, I heard Python described as the second best language for just about everything. That is pretty much true, right? If you want to do a lot of different things with one software, then Python's your go-to tool. If you want to do something specific very well, then there are always other specialized softwares out there. And Shanta, you're exactly right. If you want to just learn about visualization specifically, then Power BI and Tableau is your go-to tool. But that being said, not all sorts of visualizations would be supported on Power BI and Tableau, just because Power BI and Tableau are mostly used by businesses and like organizations that like handles like typical business hierarchies. So for a lot of scientific visualizations or custom visualizations that are required by the research industry, Power BI and Tableau would not be able to handle those, right? So for example, 3D visualizations or maybe even genetic visualizations, Python would do the job much better. Exactly. And Power BI, Microsoft's actually very smart these days. They're coming up with all sorts of integration with external open source libraries. So again, as you may have heard, they've been heavily investing in ChatGPT and all that. And the strategy that they've picked with their products is very smart, which is basically allowing integration between all sorts of different open source softwares, which basically increases adoption, right? So Power BI is also able to work with Python codes now, which makes it a great integration option. Now, again, why would you want to learn Python in the end if Power BI and Tableau can do all these visualizations? As I've mentioned, Python, it has that flexibility to pretty much deal with any kind of situation. So if you are looking for a simple visualization software, which would draw up graphs according to what your data says, then Power BI or Python or Tableau or ClickView or Looker would do the job. But if you're looking to do some sort of dirty calculation or cleaning up a very messy data set, then Python would be your go-to tool. And finally, you have Python versus SQL. Now, SQL by itself is a specialized language that is used mainly for communicating with databases. Whenever you have any structured database, then you'd be using some form of SQL, either MS SQL or MySQL or Postgres, whatever works with your database system. But the general idea is that while Python and SQL cannot be directly compared because they both have different purposes, SQL can be used within Python itself. So for example, you can always connect to a database or remote database with Python, and you can always invoke SQL commands within the Python script itself. So the flexibility of Python can be used as far as your imagination extends to, okay? If you think of a use case, you can pretty much implement the whole thing in Python. Even though it might not be the easiest thing to do, you also enjoy that flexibility to do so if you wanted to. Okay, now that we've considered all the different differences between these tools, let's take a look at what the Python library and ecosystem itself contains. Now, whenever people speak of Python, or whenever the developers or the users speak of Python, there's always mention of the standard library or the Python ecosystem or things like that, okay? Now, let's take a look at what the Python standard library and the ecosystem means. Now, the Python standard library is basically a collection of modules that are included with the Python programming language, with the core Python programming language. Now, these modules provide pre-written reusable codes for common tasks, such as working with strings, dates, and files. Now, the library includes modules for a wide range of tasks, such as the OS module, which is basically used for interacting with the operating system, including file and directory management, process management, and more. So if you wanted your Python script to interact with your file systems, either in your Linux or your Mac or your Windows, you could always do so with the OS module in the standard library. Now, it also has the string and text processing module, which is used for working with strings, including regular expressions or regex, as you may know it, and text encoding or decoding. You also have the data type module, which handles different data types, such as lists, sets, and dictionaries. You also have the mathematical and scientific computing modules, which can be used for not all sorts of computations, but most scientific computations, including matrix operations, statistics, and more. Now, while Python standard library by itself does have an internal library, there are many other different libraries, external libraries out there that make the job much easier. Okay, like if you wanted to work with Python for some sort of computation, then of course you have the option to work with the standard library module, but then I'm pretty sure there are many different other libraries out there that do the job much easier. Okay, so just taking a look through the chat again before I move on. All right, cool. So now this should give you an idea of what are some of the different modules are out there. And again, the standard library has way more Python, more modules inside it. So I would definitely recommend you to take a look at it when you have the time. So all you have to do is just search up for Python standard library on Google, and you will get a list of what all it contains, okay? Now, in contrast to the standard library, the ecosystem itself refers to the collection of libraries and frameworks that are available to use with Python. Now, these libraries and frameworks, they're developed by the Python community and can be used for a wide range of tasks. Things like web development, data analysis and visualization, machine learning and artificial intelligence, natural language processing, and even scraping and crawling. Now, in addition to that, you also have specialized scientific libraries that are used for very specific use cases. For example, you have SunPy, which is a community Python library for solar projects. And there are some of the other ones over here. I'm not too familiar with all of them, but you can always take a look at the BYPI website for all sorts of different libraries that are out there. Now, the Python ecosystem is constantly growing and evolving with the addition of new users joining every day, and with new libraries and frameworks being developed all the time. This definitely makes Python a very powerful and flexible tool for a wide range of tasks, and is one of the reasons why it is such a popular choice for developers who are both in the field for a very long time, also for the people who are just joining, okay? So if you're looking to get into programming and you've always been dreaming of a tech job or a tech career, then Python would be your starting point if you wanted to pick up programming, okay? Right. There are several new libraries presenting PyData. Yes. There are many different resources that you can use online. So again, a simple Google search does the job. All right. Now, I do want to address this one question that I got at the beginning of the session, which is not directly related to WeCloudData, but it's relevant to the field itself. Now, the question is, how will ChatGPT evolve the field of data scientist, given that ChatGPT is able to do data pre-processing and write code for machine learning? What does it mean for junior data scientists? What skill sets will I need to have to be a junior data scientist? All right, so to answer this question, again, ChatGPT, it's probably one of the best innovations I've seen after Google, and in a very long time. Like, it's not hard to say that this has to be one of the most innovative technologies that's freely available these days, right? Now, what does it mean to a data scientist or a software engineer or anyone else, right? There's always been the fear that AI is somehow going to be replacing all human jobs and things like that. But if you think about it, someone still needs to be able to go into softwares like this and customize the parameters that make the artificial intelligence generate such accurate results, right? Someone also has to be able to clean up the data or provide context to these smart algorithms so that they're able to process the data directly. While as a data scientist, you may expect that, okay, even eventually in time, the automated systems are going to be handling all those heavy lifting. So for example, you wouldn't probably need to do all the data pre-processing manually, but then you would still need to provide it the business context that it needs to understand what kind of data it should be producing, right? So for example, ChatGPT, right? It looks like it's one of the smartest things ever, but
all it is that it's able to mimic a human-like conversation, right? So it's been fed with some data from all of the internet, and that's why it's been trained on like 173 billion parameters or something, which makes it very smart, right? So up until 2021, if you ask it any kind of question, it's able to answer it to you accurately. But in the end, it cannot develop the solutions by itself. It can only tell you what it's been taught. And as a future data scientist, your job would be to make sure that it is providing the correct results, as with every other AI system that's out there. So to answer the question simply, your job is not in danger. Actually, your job is just gonna become more easier to find, because a lot of the companies, I would say that it's probably like 80% of the companies, they're still getting started with data analytics at this point. So that's basically the first step into the whole machine learning based systems, right? So you would definitely be able to contribute to that whole effort. Exactly, Hiro. As Hiro's saying, the best AI results come from combining the AI raw output with human intervention. AI by itself, until we reach, again, what we understand of AI comes mostly from Terminator, I assume, where we expect Skynet to come, take over all of us. But then again, reality is very different from movies, right? To train things like this, it takes pretty much a lot of human ingenuity, and that's where you would fit in as a data scientist or a data professional, okay? All right, so let's move forward. It's 7:30, so let's get started with the project itself for today, okay? Now, again, today's topic at hand was about the scraping of financial data using Python, and that's exactly what we're going to do. Now, to provide a bit of context into what we're going to be working with, we're going to be scraping the data from Yahoo Finance using Python and a few associated libraries. And we're going to be using that data to generate a very simple chart, or a candlestick chart. If you're into the stock markets, you'd know about that. If not, then we're going to take a look at it later as well. Okay. Now, for those who are familiar with Yahoo, I'm pretty sure you already know about all the subsidiaries Yahoo has. But for those who aren't familiar with Yahoo, it's probably one of the oldest internet companies that are out there. And one of the subsidiaries they have is Yahoo Finance. So Yahoo Finance is a financial news and information website that provides financial data such as stock prices, market data, and financial news. It was launched in 1996 and is one of the oldest and most popular financial news and information websites that you can find on the internet. Yahoo Finance provides a wide range of financial data and information, including real-time stock prices and market data, historical stock prices and financial data, financial news and analysis, company financial and earning reports, and all different sorts of tools and charts that can help you make the right decisions before you start buying up any stock, okay? Associated with that is the yfinance library, which is a Python library that is used for accessing financial data from Yahoo Finance. It allows users to easily download historical financial data, such as stock prices, dividends, and financial statements, as well as real-time financial data, such as stock quotes and market data. Now, yfinance library provides a very simple and easy-to-use interface for accessing financial data, and we're also going to be taking a look at the documentation later. It supports a wide range of financial data. So regardless of if you're interested in stocks or options or currencies or cryptocurrencies, you can pretty much download any sort of data using that, okay? All right, so at this point, I would like everyone to get your computer started, of course, and open up Google Colab, okay? So all you have to do is sign into your Google account and just search up Colab. The first link that you get on Google is where you'll be writing all your Python code in, right? So as soon as you click on that, you'd get this window that allows you to click on New Notebook. So I'm just going to wait 2 minutes for everyone to sign in and open up Google Colab, and then we'll proceed. So if you want to use VS Code, you can, but just because we're going to be using data analysis, it's easier to use some format of Jupyter Notebook just so that you're able to see what you're doing with each step, okay? For VS Code, you'll have to write the whole code and compile it, and you don't have the persistent results behind once you run the code again, okay? Is Google Colab an alternative notebook to Jupyter? Yes. So Jupyter Notebook itself is the environment that can be hosted on many different platforms, right? So Google's version of Jupyter Notebook is Google Colab. Similar to how you might have worked with Anaconda, Google also started offering their notebook environments to users. Okay. Now, if you've reached this stage, all you'll have to do is click on New Notebook, and it'll open up a new notebook for you over here, okay? So for those who are already familiar with Google Colab, or Jupyter Notebook in Anaconda, you might already recognize some of the UI, but for those who are totally new to it, let me just quickly explain to you how Google Colab works or Jupyter Notebook works, okay? Now, whenever you're working with data science or data analytics, Jupyter Notebook or Jupyter Lab or some format of that is most likely one of the most popular options that's out there, okay? The reason being that, first of all, you can treat it like a document editor, something like Google Docs. So whatever you type out and run, the results will be persistent, which means that, let's say I type out a simple hello world. Just give it a second to connect and run it. And it prints out the output over here, okay? Now, if I try printing out something else, the output that I've received from the first code that I've run does not get wiped. So as compared to some other kind of IDE, which, for example, like Visual Studio or something, if I tried running it on a terminal or on the Python CLI directly, then it would wipe the previous result, right? So to a certain extent, using Jupyter Notebook is very useful for data analytics, as you are able to see the historical results of what you've been working with so far, okay? Now, the Jupyter Notebook, it has different formats, have different kinds of cells, but when it comes to Google Colab, you'll only have to be concerned with 2 types of cells, okay? So first of all, each cell is this box that you're looking at. So this is a cell, this is a cell, this is a cell, okay? Now, cells, they come in 2 different types in Google Colab. One of them is the code cell. So if you click on the code plus over here, in the code cell, you're able to type in a valid Python syntax, and if you run it, it'll provide you the output right below it. As for a text cell, what you can do with it is enter HTML or Markdown. Okay, so HTML is basically the language that is used to create the document part or the text part of the of websites. So if you already know HTML, you can always enter HTML here. Markdown is just an extension of HTML. So it basically, what Markdown and HTML helps you do in Jupyter Notebook is provide more context into what you're doing, right? So for example, I wanted to write over here that, okay, heading is web scraping for financial data. Okay, what it does is it allows me to create a text heading on the whole document so that anyone who's reading this document is able to easily understand what the context is. Of course, you can always rename the file itself at the top over here, but having the option to put in heading or paragraphs or text like that, or even images and links, it provides more flavor to the document that you're working with. In contrast to VS Code, you can definitely run all the codes, but you wouldn't be able to put in the flavor to explain the notebook better to anyone who's viewing it. Okay. So what I'm going to do is I am going to quickly rename this notebook to web scraping, or actually scraping financial data. And I'm just going to leave this over here. Now, whatever you have cells like this, you can also have multiple options on the right side over here. So if you want to move it up or down, you can use these arrows. If you wanted to link it to a certain cell, you can use that as well. Commenting options. You can open a separate tab over here if you needed two screens to look at the same document, or you can choose to delete it in addition with other options over here. Okay. So for now, I'm not going to go too deep into all these different options. So we'll just jump right into what we're going to do for today. Okay. Just going to remove all these. Okay. So the first step to any data analytics or any Python code, right? You'll have to import the required libraries. Okay. So first off, Python by itself, it comes with a standard library, so you don't need to import any of that as long as you're running the Python engine in the backend, it comes with all the libraries, okay? So for Google, it's the Python 3 Google Compute Engine backend, so that loads up all the standard library resources. Now, we do need a few other libraries to work with the data today. So the first thing we're going to do is import the pandas library, okay? Now, the pandas library is one of the Actually, it's not one of the, it is the most popular library when it comes to working with tabular data. Whenever you have data that can be arranged in tabular format, which is basically rows and columns of data, then pandas would be your go-to library just because of the support and the capabilities it has of working with tabular data, right? Now, I'm just going to quickly import this library and give it an alias called PD. Okay, so whenever I try to invoke any function using the pandas library, I don't have to keep typing out pandas. I can just type out PD. In addition to that, I am also going to import the datetime library. Just because we're going to be working with datetime figures in the stock data, we're also going to be needing the datetime library. Okay, so I'm just going to run this, and as soon as you see a little green tick on the left side, it means that that cell has run properly. If there is something wrong with the cell, then it's going to throw an error like this, okay? The other thing about Google Colab, in contrast to Jupyter Notebook and Anaconda, is that you have this option over here, which allows you to search Stack Overflow directly. You don't have to copy and paste it in Google. You can just click on this and it will open up a new page, which allows you to search what the error is. So it's a very nifty trick to have. Open examples, this is also new. Okay, so if it seems that if you try to do, if you cause an error that is recognized by Google Colab directly, it will also offer you some support there. Okay, so I'm just going to fix this. All right, now the first thing we need to do is, let's say that you want to compare your portfolio of stocks and contrast it to the S&P 500, okay? So S&P 500 is basically a list of companies that are considered the top 500 companies out there, the publicly traded companies, okay? So I'm just going to paste the link over here. So this is basically the Wikipedia page that lists all those companies, right? And this is the data source we're going to be using to get all these symbols first, okay? Now, the idea is that we're going to be using these symbols over here in conjunction with the yfinance library to scrape the data that we need, all right? So let's say that you're interested in the S&P 500. What we're going to do is we are going to scrape this page over here, okay? So one of the easier ways to scrape a page is by using the pandas read HTML, okay? So if you search up pandas HTML, what this function does is it takes an HTML argument and it parses the tables inside it, okay? Now it won't read everything that is contained within the page. It'll only pick up whatever is classified as a table, okay? So in this page, you have one table over here. So scroll down. And then you have another table over here, okay? So you have a total of 2 tables in this web page. Now, what the read HTML function does is it reads the HTML tables into a list of data frame objects, okay? So we're going to do exactly that. The first thing I'm going to do is I am going to assign a variable called webpage and invoke the read_HTML function here. Now, the read_HTML function can take in a bunch of different parameters, but it only has one of them which you need to fill up, which is the string path, the path itself, where the table is being read from. All the others are optional. If you needed to customize the way that the data is being read, you can always use these options, but since we don't need these, we're just going to skip all those, okay? So what I'm going to do is just pass in the path itself. So the path is the URL that I'm going to scrape, okay? And I've already posted the URL in the chat, so you can just copy it from there. So for those who are totally new to Python, I'm just going to give you a quick rundown of what I'm doing. So what I'm doing over here is I'm using the pd.read_HTML function. I am giving it a parameter, which is the website itself. And whatever data is being read from this function is going to be assigned to this variable called webpage. Okay. Now, if I run this and I try to see what's in their webpage variable now, it will show me whatever's been read off of Wikipedia. Okay. Now, this might seem gibberish right now. So what we're going to do is use other tactics to understand what we have scraped so far. Okay. So what I'm going to do is remove this. And the first thing that you can try whenever you're working with data that makes no sense as you print it out is take a look at the type and length. Okay. Those two would give you a good idea of what the variable itself contains. So I'm going to do exactly that. So type webpage tells me it's a list. And now you have webpage length, which means 2. Okay. All these two functions are doing is that it's telling me that the webpage variable contains a list and it has 2 elements inside it. All right. Now, since we already know the context of what we're scraping, it's easy to say that, okay, this is table 1, this is table 2, and those are the 2 tables that scraped from it, right? But if you're working with data that you have no idea about, it's always a good idea to explore the data using basic commands like length, or even accessing the list itself directly to understand what you're working with, okay? So to mimic a bit of that, what we're going to do is quickly check what each of these list elements look like, okay? So whenever you're working with lists, again, if you've been working with Python, you should already be familiar with this. You can always access list elements with the square brackets, right? So if I wanted to, let's say, access the first element within the list, I would say webpage 0. And that would give me one of the tables that comes from this website over here, okay? So you can see that the first table is the one over here, which basically contains symbol, security, SEC filings, GICS sector, sub-industry headquarters, date indicated, date added, CIK, and founded, okay? So that's the first table, and the second table should contain the change or the change log for the S&P 500 components, okay? Anything that has been added or removed from the list, this is what that table contains. So over here, if I were to type out 1, that's what it would give me, okay? Now, for the company tickers itself, I only need the first table, which is this one, right? This one basically contains all the 500 companies over here, and we're going to be extracting the unique symbols from here. Okay, I'm just going to pause for a bit and just check in with everyone. Is everyone able to follow along? All right, cool. So, all right, let's move on then. The code, yes, for sure. So I'm just going to keep posting the code in the chat as I'm typing it. So if you're missing out, you can always just copy and paste. So type, and then you have length. Then you have the accessor over here. All right. Okay. Now that I know that my first element within the web page variable contains the table I need, what I'm going to do is isolate what I need. Okay. So instead of just calling up web page 0 all the time, what I can do is initiate a new variable called company_df and assign whatever is being scraped, whatever this element contains. Okay. Which basically means that this table is now going to be inside company_df. So I'm just going to run this. And if you run company_df, now, if you don't want to show all the rows in the table, or just to quickly get a glance at it, you can always use the head or tail method, which basically either shows you the top 5 or the bottom 5 of a list by default. Okay. So I'm just going to say head. The number is 5 by default, but I'm just going to say 10 over here. So it shows me the first 10 rows. Okay. Now I know now I can confirm that the company_df variable has the table that I need over here. Okay. All right. Now, let's take a look at what the company_df itself contains. Okay. When we scraped it, we know that the type method showed that the web page contained a list and it had 2 elements. Now let's take a look at what each of these elements are from seeing what this is. Okay. So I'm going to just run the type command again with the company_df. And it tells me that it's actually a pandas data frame object, which means now I can access and use all sorts of different pandas functions on this data frame over here. Right. So whenever you're working with a list data that you want to work with pandas functions with, try to convert that into a pandas data frame, and then you'll be able to use all these different kinds of functions on that data frame. Okay. Now, the way to do that is, for example, let's try it with this list itself over here. Okay. Now, what if I wanted to convert web page into a data frame? All you'll have to do is, okay, Ricardo, you're exactly right. If you wanted to convert a list to a data frame, that's exactly what you do, right? But since pd.read_html is already converting the red tables as pandas data frame, you don't need to convert that. Okay. So referring to what Ricardo is talking about, let's say that you have a variable that contains a list, okay, and you wanted to convert it into a data frame. Okay. So I'm just going to say test is equal to pd.data frame, pass in the list over here with page, and then check the data type test. So you see that it's actually being converted to a data frame. So if you ever wanted to convert your lists to a data frame, use this method over here. pd.dataframe, pass in the list, and you will get the data frame. You'll get the return as a data frame object. Okay. All right. So let's move on. Okay. So now that we know that we're working with a data frame object as company_df, you can also run the shape method on it just to take a look at what it contains. Okay, so company_df.shape. And what it'll do is it'll show you the number of rows and the number of columns that are inside this. Okay. Now there is another way of doing this, but in a more comprehensive manner, is by running the info method. Okay. If you do that, it's going to tell you multiple things. First of all, the class or the object type. Then you have the range index, which basically means that how many rows of data you have. Okay, so 503 rows of data ranging from 0 to 502. And also gives you a description of the columns that are inside it, including their data types. You also get a memory usage over here, so 35 KB. Okay, so if you're working with different sizes, or if you're concerned about the size, or you want to know the sizes for data frame, then you can always use this method to get a description of it. Now, let's say that you are working with some sort of numerical data that you want to run some statistical analysis on, right? Maybe you have some sort of measurement data that you want to check the statistical description of, okay? You could always use the describe method for that. So I'm just going to type out describe. And what the function by default does is that for every numerical field in the table, it will provide a exploratory data analysis menu for that. Okay, so you have the count, mean, which is average, standard deviation, minimum, 25th percentile, 50th, 75th percentile, and maximum. If you wanted to include everything inside it, which doesn't make sense for categorical variables because you cannot calculate statistical numbers from categorical variables. You can always use the include all method, and that would give you the count or the statistical analysis for every column in the table. Okay. But then again, since we're not going to be working with statistical data over here, we don't really care about this. So again, this only matters if you're trying to work with statistical data. Okay, so now let's take a look at what we need first. Okay, as we said before, we need the tickers or the symbols itself over here, right? So there are duplicates over here for sure. One of the ways to make sure that you're only retrieving the unique values from a list is by using the unique symbol. Okay, so what I'm going to do is say company underscore df, and I'm going to specify which column I want to derive from, which is going to be the symbol column, and I'm going to pass in the unique function at the end. Okay, now as soon as I do that, what it does is that it extracts all the unique values from the symbols column in the data frame of the company underscore df. Okay, so if you ever wanted to isolate unique values, this is your method over here. So what it does now is that you can see all these different kinds of tickers over here. You might recognize some of them. There's Google, there's Amazon, there's Adobe. Let's see what else I recognize. I have Meta, that's Facebook, and a bunch of others down here, right? It's gonna take a while to go through everything, but you get the idea. So now that you know that you can isolate the stickers like this, you can actually use this idea to isolate the things you need, okay? So for example, let's say you are interested only in a specific business sector, right? Let's say, looking back at the table over here, you can actually see that each company is actually classified as a specific sector, right? You have industrials, you have healthcare, information technology, communication services, a bunch of other things over here, okay? They also have their headquarters, a data added, anything that you might need to use. Now, what if you wanted to only focus on a specific industry like energy, right? Let's say that, let's take a look at what all sorts of industries are actually available in this list first. So similar to what you've done over here with the symbol column, I'm just going to copy and paste this over here. And instead of running symbol, I am actually going to take a look at the GICS sector. And what that does is it shows me the unique categories that are available within the S&P 500 list, okay? So you have industrials, healthcare, information technology, communication services, staple, consumer discretionary, utilities, financials, materials, real estate, and energy. So depending on what kind of portfolio you specialize in, maybe your portfolio entirely consists of utilities, or maybe even information technology or materials or financials, you'll be able to isolate what you need using this method over here, okay? So let's say that I only want energy, okay? Now that I know that energy is part of the categorization in this table, what I can do is use this over here as a filter on the whole company underscore DF data frame, okay? So what I'm going to do over here is initiate another variable called comp energy and start filtering the existing data frame. Okay. Now, the way that you filter a data frame is by passing it a specific parameter. So for example, I want to filter company underscore DF. Within square brackets, you can pass it in a filter. Okay. So where you can say company underscore DF GICS sector is equal to energy. Okay. Just typing it out. All right. So again, this one you might already recognize by itself, right? You're just calling up the data frame. What this part does is that it'll try to return every row of data where this is true. where the GICS sector is energy. As long as this condition is met, it will return that row of data. Okay. And all I'm doing is I'm running this piece of code, assigning the results to this variable over here, and I'm going to see what the results are. Okay. So what I've just done is I've isolated. Yes, you can also use ilock and lock as well. Ilock and lock are a bit more complicated for beginners. That's why I left it out. But if you're interested in ilock or lock, that is also a very easy way to do things. Okay. So again, like, if you're interested in doing things in a different way, or like, in a more efficient way using the pandas library, you could always take a look at what the documentation itself says. Okay. So let's say that you wanted to use ilock in pandas. You can take a look at the documentation and see what the function offers you. Okay. So first of all, you can say, okay, purely integer location based indexing for selection by position. Does anyone else not have my audio? Okay. Yeah, Steve, you might want to check your headphones, I guess. Okay. So ilock is the way to access a data frame using the index values only. If you want to run it using the column names, then you would be using the lock function. Okay. So again, I'll just leave this for you to explore by yourself. If you have questions, you can always just reach out to me with the contact I'll provide you later. Okay. All right. Now, let's see where we are at. Okay. So let's take a look at what the comp energy contains, just to verify that we have extracted everything from the energy table, okay, or whether this data frame only contains energy. So similar to what I've done before with this over here, company underscore GICS sector. I'm just going to make sure that I'm referring to the right data frame over here, which is comp energy. And it tells me that there's only energy over here. Okay. Larry, was the link to the Google Python Colab shared earlier in the meeting? No. So Google Colab is offered by Google as long as you have a Google account. So as soon as you sign into Google, you can just search up Google Colab. You get a notebook like this, click on this, open up a new notebook, and you get the same environment that we're working with over here. Okay. All right. So let's take a look at the symbols that were drawn from this energy filter. Okay. So you can actually see that the list of symbols have actually decreased, which means that all of these are actually energy, and that was proven by the previous code that I ran. So I'm just gonna keep this here. So you have GICS sector and symbol. Okay. So comp energy contains only energy, and the symbols it has are these over here. Okay. I'm getting someone has an error. Okay. So company underscore df GICS sector energy. Okay. So Billy, you might want to run the part where you are initiating your company underscore df variable. So without the company underscore df being initialized, it won't exist. So you need to run this part over here. Okay. No problem. Okay, so is the symbol acting like a unique identifier? Yes. In the context of uniquely identifying the stock mark, or the stocks itself, or the stock offering, then the stock ticker is your go-to factor. Okay. The name by itself, or the security name itself, can be used as well to a certain degree, but then again, it's better to use the symbol, just because this one has the guarantee that it will be unique. Okay. After exploratory data analysis, what other analysis we'll be doing? So for mainly today, we're going to be exporting all the data that we're going to be working with, and also drawing up a simple candlestick chart using the data that we're going to extract. Okay. All right. So now that we have what we need, okay, what we're going to do is import the yfinance library. Now, you can always import it from the get-go itself if you already know what you're going to do. But since we're going at it in a way that we are completely doing it from scratch, we're going to be importing the yfinance library now, okay? So to import the yfinance library, all you'll have to do is type out import yfinance and give it a alias spelled YF, okay? Now, if you run this and if you see that it's not running, then you're going to have to first install yfinance in your environment, okay? The way you do that is by running the pip installer, which is basically the package installer for Python. And you can just specify pip install yfinance. So you can just run this piece of code. And it will give you a bunch of prompts over here that says like it's loading the yfinance library, it's installing everything. And it'll ask you to restart it if you have the same issue as mine, okay? It says that there were beautiful soup HTML5 lib and requests was already there, but you need to restart the runtime to use newly installed version. So you can just click on restart runtime. Yes. Okay. So if you've restarted the runtime like me, what you'll have to do is click on runtime. After it's restarted, you have to click on runtime and click run all, just so that all the variables that we initiated before is still active. Because once you restart your runtime, anything over here that you've defined, like for example, comp energy, company_df, it all gets wiped. So you'll have to run everything from the top again. And easier way to do that, go to runtime, run all. So I'll wait 2 minutes for everyone to do that. And until then, if you have any questions, let me know in the chat. Okay, so what can yfinance do? Now, yfinance, it's a library that allows you to interact or interface with Yahoo Finance. You can do many different sorts. You can do many different things with it. Let's take a look at yfinance. So you can take a look at the documentation here for more details, but generally what it does is that first of all, it allows you to scrape data given a bunch of given specific prompts from Yahoo Finance, and you can use it to download different kinds of stock data or financial data from Yahoo Finance. Okay. Now, the kind of things you can do, it's always constantly being updated. So for the best explanation, take a look at the documentation, you'll get an idea. Or better yet, ask ChatGPT. That's what I've been doing recently. That's all I've been doing recently, actually. So what is yfinance? It's going to leave this on the side. Okay, so I'm assuming everyone's reached until this point over here. I'm also going to paste this over here. Yes, so the last bit of code is I installed the yfinance library, and then I imported yfinance, renamed it with an alias YF. Okay, so let's move forward. All right, so let's take a look at the yfinance documentation itself, okay? This might not be as easy to use. Yeah, it looks like this is the only documentation that's Never mind. All right. So when you have the time, you can always take a look through this documentation over here. But what the yfinance library basically needs is a few things. Okay. So the one function that we're going to be using to download the data is the yf.download. Okay. So you can say yfinance download syntax. Trying to find a good resource library. Okay, I'll just tell it to you. All right, so the few things that you need is, first of all, you need the ticker symbol, which is basically what we got over here. You need a start date and you need an end date. Okay, so as long as you have these three elements, you also have other options to customize the YF download function with, but as long as you have the ticker date, the ticker name, the start date, and the end date, you'll be able to draw the data from yfinance. Okay. After importing yfinance and running cell, restart runtime, choosing run all to rerun all cells automatically. Yes. Will this notebook? I will provide a link to the notebook after we're done, just so that you can catch up with anything that you may have missed out on. But then again, if you're able to just try it by yourself as well now. Okay. All right. So since we know that we need three things, which is basically the syntax. Okay, so these are the three things you need. So we already have the first one, which is the ticker. We need a start date and an end date. Okay, so to do that, what I'm going to do is just open up a variable called start date and use the datetime method. Okay, remember how we imported datetime at the top? What we're going to do is just input a datetime, which is going to be starting from 2021. What's the date today? 01/25. Okay, 01/25. Okay, so that's 2 years of data there. And for end date, say datetime dot today. Okay, let's see. All right, so now if I print out start date, end date, it gives me the start date, which is 25th of January 2021 until today, 26th. Not sure what's from me 26th, but I think it's the Python's engine. Anyways, 26th of January 2023. Okay, these are the start dates and end dates we're going to be using. Okay, now what we're going to do is open up another variable called stock price. Okay, and what we're going to do is make, yes, it is UTC. That is totally correct. So it's basically showing in the UTC format. Okay. What we're going to do is initiate a variable called stock price and invoke a data frame object inside it. Okay. So all I'm going to do is create an empty data frame object inside stock price so that I can write things to this variable over here. Okay. Now, if I do this, like stock price, it'll tell me that stock price is now an empty data frame. Okay. Now comes the part where you start downloading the data. So the way that you can use the YF download in many different ways to append it over here, but let's take a look at it in a simple way first. Okay, just by initiating a simple data frame and see what kind of data it downloads. Okay, so what I'm going to do is just open up a general variable called df and type out the YF download method. And let's try out with APA first. Start is equal to start date, and is equal to end. And let's run this. So you get these kind of data over here, okay? So as soon as you run the YF download method, first of all, if you're already familiar with stocks, then you already recognize these. For those who are not familiar with stocks, it's basically the opening value, high value, the highest value that it is achieved in that day, lowest value, the closing value, adjusted closing value, and the volume of stocks that's been traded that day, okay? Now, if you're working with stocks, you already know how important these are to assess the viability of a stock. For those who are not aware of it, I'm not going to go too deep into the stock market trading, but it basically helps you gauge the performance of stocks as it moves through each day, okay? Now that we know that we can download a set of stocks using this function over here, let's try to use the tickers we've got here to download the data, okay? So if you remember, we call this comp energy symbol unique, okay? I'm just gonna put this over here so that I can see it. And what I'm gonna do is use a for loop so that for every ticker in here, it's gonna read this ticker and it's going to run this piece of code over here, okay? And that way I can get the data that I need for each of these tickers for all the energy portfolio, okay? Could you explain the code line number 18? Okay, what I did when 18 was I initiated a simple empty variable called stock price, and I assigned it with a class with a data frame object, okay? Now variables, they can take on the data type of whatever is being assigned to it. So I'm trying to assign a empty data frame to it. That variable becomes an empty data frame. Now I can do all sorts of data frame operations on the stock price variable, which includes appending things to it or adding lines to this data frame. Okay, all right. So for loops. Now, again, if you're familiar with Python, you would already know what for loops are. For those who are unfamiliar with Python, for loops are basically used to repeat a block of code or a piece of code over a certain number of times, okay? You can specify a specific condition using a while loop, or you can specify the number of iterations using a for loop, right? Now, what you can do in Python is that, let's say that this over here is generating a list, right? I can use the length of this list as a counter to iterate a specific code through, okay? So what I'm going to do is say for I, or variable I, in whatever's over here, run this piece of code. Instead of APA, I'm going to be using I, and over here you have df symbol equal to I. I'm going to be explaining the code as after I finish it. Stop minus and df and df don't have it. Okay, try this. Okay, looks correct. Yes, not, I wouldn't say this is a recursive function. I would say this is just a normal for loop, right? Recursive function is basically something that calls upon itself. So for example, if I wrote a function over here and then call the function again within itself with a branching loop, then that would be recursion. But this is technically what you said, it's appending all the values, okay? So to explain to explain what's happening over here, for I in company energy symbol dot unique, which is basically for every variable in this list, assign it to the variable I, and then use that value of I in the code over here, okay? So now I in the first iteration contains APA. It's going to extract that information using the function that you saw before. And df is already a a data frame that you used over here, right? Or you initiated over here, okay? Now df is going to be overwritten by whatever is over here. And it's going to add in a new column called symbol. And for that symbol column, all the values in that symbol column is going to be I, which is going to be APA in the first iteration. Okay, so first you have, let me get my pen here. Okay, so with this over here, okay, you're getting a data frame that is putting up high and close, low, and things like that, right? After this is done reading for APA, you're also adding another column over here called symbol. Okay, and for every row of data under that column, you're replacing it with I, which is APA. Okay, so now you have the APA symbol beside every row of data. Does that make sense? Okay, I'm going to assume it did. If it didn't, let me know, and I'll cover it again at the end of the session. Okay. All right. After that, whatever this data frame contains, I'm appending it to the stock_price data frame, empty data frame that I opened up over here. Okay. Now, this is the external container that will contain every data point that's being read as this iteration goes through. If you only use df, this df will get overwritten with every iteration, right? So once this loop starts, df gets overwritten by this, right? So you need an external container to store whatever is being read, okay? And I agree with Larry. I should probably not use I should probably use something that is more obvious. That is totally true. Whenever you're naming variables, try to make it intuitive, so whoever's reading it has an idea of what you're trying to refer to. So I will do that as well. How does a for loop end? So the for loop ends when it reaches the end of the, where is it? There. Okay. This list over here has a specific length to it, right? So as long as this list is not ending, this for loop will continue. As long as this list has ended or it doesn't detect anything after this for loop will end. Okay. Hope that made sense. When basically, to define it simply, for loop depends on the number that you assign it. Like, let's say you want it to run 5 times, it'll run 5 times. You have to specify how many times you want it to run. If you want it to loop on a condition, then you would be using while instead. Are you creating a list of data frame with stock price? Okay, so what I'm doing over here is that this data frame that I'm getting per iteration, right? I'm just appending it to the existing data frame that I created outside, which is over here. Just gonna move this down here. Okay, so that whatever is being read in a single iteration is retained within this stock price data frame. And for the next run, whatever is being read again will get added or appended to this data frame over here. If that makes sense. Okay, so I've also included a print df_df.head over here just to take a look at what's happening for every iteration. So that's where you get this like list over here that says like 100% done, and then you have these options over here or these values over here that's showing what's happening every iteration. Okay, this might not make much sense, but when you print out the table itself, then it will make a whole lot of sense. Or you can just like run df.head. Should print out the it does not print that out. Okay, I was trying to print out the data frame in this format itself, but looks like I have to convert it to a data frame first. Never mind. So it depends at the end of the existing data frame, it's not creating a list of DFs. No, it's just appending it. Because again, I'm using the append method, right? Okay, if I do it outside the for loop, it's not going to show me every run because this, for example, if I run it outside, right? This piece of code will only be executed after this loop is completed. So it's only going to show me the last line. So the last instance of df, like let's say if I run this, it's only going to show me the last one. Okay. So one of the fixes with that would be let's take a look at what type this is again. Okay, just for the sake of time, I will leave it as it is. Can't you print stock price TF? Yes, I will be doing that after this. So the point over here was just to show that df.head would be showing you the values that is being, the top 5 values that's being read for every iteration. That's why you get this result over here, okay? Can you explain again what this for loop is outputting? Again, what this for loop is doing is that it's taking every variable from the symbols from this comp energy, and it's using those stickers to download the stock data. Okay, so for APA, it's downloading the data from the start date until the end date, and then it's going with BKR, and then it's going with CVX, and with every iteration, it's being added to stock price over here. Okay, so now if I say stock price, it's actually going to show me a table which has the symbols as well as the values of each stock decided in addition to the date. Okay. Now let's say that you're interested only in the APA values, right? Similar to what we did before with the filter, you can do the same over here as well, which would be brackets. Keep getting the syntax wrong. Stock, price, symbol. Okay, that would only show you APA. So you can always use the filter method, the filter technique to find out the stocks that you need. Okay. All right. Now, so we already have a data frame that contains what we need, right? So for example, if you wanted to only check for APA, you could do this. And let's say that you only want to retain APA, right? So I'm just going to say APA is equal to this. So whenever I run APA now, it's going to give me the data frame that contains only the APA values. Okay. All right. Now, I hope this all made sense so far, because I'm going to move on to the visualization aspect. Okay, cool. I also hope that you're understanding, like, let's say that, okay, maybe you're not interested in energy, right? Maybe you're interested in Tesla or whatever, right? As long as you replace this properly, you will get the data that you need. Okay, maybe you have your own list of tickers that you want to track. You could always do that as well. So create a list of those stickers that you want to track, use this piece of code, and you will find the resulted values in stock underscore price. Okay. Now, of course, there are easier or more efficient ways of doing things, but just because this is a tutorial session, it's a bit more in-depth or more branched out. Okay. You could probably run this whole thing in like 3 or 4 lines of code. All right. Okay. So let's say that you have the APA symbols over here. Okay. Now there are many different libraries that are out there, as I've mentioned before, that are used for visualization and all sorts of different things. One of the ones that I've been particularly interested in is called Plotly. Okay. Now this library is very, very great. I really like the visualizations it has. And I think Dash is also by them. Someone was mentioning Dash before. So Dash is also by Plotly. And let's take a look at the graphing libraries that they have. Okay, so when you enter the Python open source graphing library, yes, give me 1 second. Let me just paste that code. So when you take a look at the Python library for visualization, right, you can see all different sorts of things that you wouldn't really expect like Power BI or Tableau or Looker to have by default, right? Power BI definitely has that external option for you to work with, but other visualization softwares, they wouldn't be able to deal with it. So is Plotly and matplotlib one and the same? No, it is not. Matplotlib is more of the basic visualization library for Python. And based off of matplotlib came all the other ones like Seaborn, even Plotly, I think it's based off of matplotlib. So matplotlib was the initial starting library for all the other visualization libraries. But it's definitely the most popular one out there. Okay. Plotly, it's more for like, pretty maps and stuff. So if you're interested in doing all different sorts of visualizations, even AI or ML apps, you can use Plotly. Okay. Now, the one that we're going to be considering for today is the candlestick chart. Now, for those working with stocks or interested in stocks, you might have already been working with something like this. And this is the one that we're going to be using. Simple candlestick chart with pandas. Now, the best thing about Python, or to be honest, like programming these days, is everything is available on Google. Regardless of what you want to do with programming, you can find everything online, okay? The hard part is building the context itself. So what do you actually want to do with the data, or how do you actually want to process the whole structure so that you reach the end result, right? But the way that, if you know what you need to do, the way that you do it, take a look at the documentation, okay? Pricing. Sorry, I don't have a clue what you're referring to. All right, never mind. Okay, so all I'm going to do is, again, I could just copy and paste this there and change the values as needed, but I'm just going to copy this and just write it out myself again later, okay? So I'm just going to copy this here. This is just a point of reference. So you can start looking at the parameters that it can accept, right? So first of all, you need to pass it a data frame, okay? Now the data frame itself will be from what we have over here, which is APA, okay? Fig is equal to go figure, which is basically you're initiating a variable and invoking the graph objects function called figure, and then you're going to pass in some parameters in here, okay? So the first parameter is data, okay? So the data itself will be the df called the df index, okay? So what you need is date here, right? According to the example, the date in our APA data frame is actually the index over here, okay? So if you want to use the index, instead of writing out df date, you would just say df.index, okay? Now, if this index value itself was actually a column, then you would just use the df date column, okay? All right. Then you need the open value, which is going to be df open. Then you need the high value, which is df high. You need the low value, df low. You need the close value, df close. Okay. Range slider, do I want it to be false? No, I don't. Okay, as simple as that. Just by changing a few things over here, I was able to draw up a candlestick chart, okay? And this is probably the best part about Python, that a lot of the things that you want to do is already available in libraries. You just have to find the right library and customize it a bit as you need it, okay? Now, with this range slider, what you can do is actually zoom into things. So for example, I want to take a look at a specific period of time that I'm interested in. I will just use the range slider and focus only on that. And if you hover over the individual ticks over here, you can actually see the explanation or the details for that day. So August 18th, there was a bit of it closed lower than the opening value, and you can see trends like that, okay? And using this range slider, you can also see the overall trend over that specific period of time. Now, if you're really into stocks, you most likely will not be using this range slider over here just because there are way better tools out there that can do the job for you. But maybe you need the data to be exported, right? Maybe you need the APA data for a specific time of year. Or maybe you want to just work on your data skills and build your own dashboard using inspiration from whatever you've been working with already, right? So Again, like I've mentioned before, there are way better tools out there for visualization contrasted to Python, things like Power BI, Tableau, and other things. Okay. You can always use those as well if you really want interactivity. For Python, the interactivity extends only to what the library provides you. Of course, if you're a whiz, if you're a developer or like, coding whiz, then you would probably be able to customize all these different outputs, right? But I guess that kind of beats the point of using libraries. All right. So how do you export it? So let's say that you have the APA data frame over here, right? What you'll have to do is actually let's not use the APA data frame. Let's use the whole stock price so that you have all these different symbols in there as well, right? Maybe you've used the stock price data frame to scrape a specific list of values for the portfolios that you're tracking. Okay, so what I'm going to do is I am going to reset the index so that this date column over here, or the date column over here, also becomes a column and not just an index. Okay, so if I say reset index, what it does is that it converts that date index into a date column, and now the index is replaced by numbers over here. Okay, I'm just going to cleaned is equal to stock price reset index. So cleaned basically contains the date as a column. And finally, I will use the cleaned dot to underscore CSV. Let's call this stock price export CSV. You can do in place index as well. So for example, if you wanted to use stock price itself, then you could do like, in place true, right? But let's assume that you are not going to be using stock price itself. Maybe you want to use a different variable, then you don't need to do this part, okay? All right, so over here, you can specify the index as false because you don't really need 0, 1, 2, 3, 4, 5, 6, all these things. It'll be included with the CSV itself, okay? Because I was thinking introducing too many data frames can be bad for memory. Yes, you are right. If you have multiple copies of the same data, then that's pretty much inefficient, right? That's what I was saying. Like, if you're the only one working on the code, you could probably just get away with writing one long line of code, right? But that's not going to be very readable once you come back to it. So for readability's sake, we'll just use this. But if you are interested, you can always use in place. Okay. So I'm just going to specify index is false, and I'm going to export it. Okay. Now with Google Colab, all the files that you are going to be exporting or importing, you can handle it using this file handler over here. Okay. So after I ran this one showed up. Now what you can do is you can download this. Just quickly download it. I do apologize because I do realize that we are 7 minutes over time. I will take up like 10 more minutes if that's okay. All right, so let's take a look at what we've done so far over here. Okay, so I just opened up the stock export CSV that I just exported, and you can see that this basically created a data set with every symbol, every information that you need for these sticker markers. Okay, now all you'll have to do is, if you want to repurpose this for your own portfolio, you'll just have to change the ticker markers, and then you can either directly run that piece of code inside Power BI and connect it directly to yfinance or Yahoo Finance, or you can export it as CSV files and then use your own technique later to work with this data. Okay. All right. So, cool. That is pretty much the end of the workshop, or as far as the coding is concerned. So I would just like to talk a bit more about the bootcamp, about the Applied Business Intelligence Bootcamp. Okay. So, as I've already mentioned before, I'm the program manager for the Applied Business Intelligence program, and WeCloudData also offers different kinds of data concentration bootcamps. Okay. So if you're one of those people who is looking for a career shift, or you're just looking for upskilling yourself in the data field, we would definitely be the person to talk to, or the company to talk to. Okay. So as far as the business intelligence bootcamp is concerned, we run our classes for a total of 12 weeks. Okay. That's 3 months. Now the classes are for 4 days a week from 7 to 10 p.m. Monday to Friday, with one of the days being an Ask Me Anything session. During the bootcamp, you will be learning all different sorts of things, but the main concentration is on the 5 data tools, which is basically going to be Python, SQL, Tableau, Power BI, and Excel. And in addition to that, we'll also be working with 8 industry-grade projects, which are not just simple visualization or dashboards that you'll be working on. It will be full end-to-end use case projects, which basically takes you through a business problem and how do you use multiple tools to solve that business problem. Okay. In addition to that, we'll also be having the portfolio building sessions, which will help you compile all those different projects that you're working on during the bootcamp into a specific portfolio that you will be later using to highlight your skills and expertise to the hiring managers. Now, in addition to that, we also have the career support session, which is inclusive of the packages that you can avail. And the mentorship program is basically for 6 months. And depending on your career choice, you can always choose from a list of mentors who are experts or data professionals in different industries out there, right? So most of them are like hiring managers or data managers, and they would be the ones to help you in your search for that next data job. As for the classes itself, we have 2 upcoming cohorts. So the next Eastern cohort starts on April 3rd until June 22nd. Right now, we're still running a 15% discount until February 3rd. After that, it'll drop to 10% until March 3rd. And after that, it'll be 5% until March 31st. If you're joining from the Western area region, or you're looking for Western timing, which is going to be 7 to 10 p.m. PST, then you can also consider the Western cohort itself, which is going to be starting on June 5th from until August 24th, 15% discount until April 7th, 10% discount until May 5th, and 5% discount until June 2nd. So for more information, you can always take a look at our website at WeCloudData.com under the business intelligence page, and you'll be able to get all the information there. Now, after the bootcamp is done, you will be supported by the WeCareer platform, including all the mentors that are listed in the WeCareer website. Feel free to take a look through the list over there. And again, the support and the mentorship cost is inclusive of what you'll be doing, what you'll be paying for in the bootcamp. So all alumni of the Business Intelligence Bootcamp are eligible for free mentorship. So just a quick overview of some of the companies that our previous alumni have gone on to work for. Again, not enough space to fit everything in here, but pretty much highlighted the major ones here. So it gives you an idea of the kind of diversity of the jobs that are available out there, plus the kind of jobs that our students are landing. So if you're ever interested in joining any one of these companies in a data-oriented path, feel free to reach to our program advisors to our website, and we'll be really happy to help you, okay? And finally, that brings us to the end of our session for today. Now, I do realize that a lot of you asked for the link to the notebook that we're working on. So I'm just going to do that as well right now. Give me 1 second. Okay. Should be able to view it now. Yep. Okay. So you wouldn't be able to edit my copy, but you can always copy it to your Drive folder. All you'll have to do is click on copy to Drive, and you'll get a copy of this whole thing in your Google Drive. Okay. And for the website, yes, it is WeCloudData.com. I will just leave this page up here so you can always refer to this. If you want to take a look at the business intelligence course, you can find it under courses and business intelligence bootcamp. If you're interested in something more advanced like data science or artificial intelligence or data engineering, the details are also available over there. You can also reach out to me on LinkedIn. All you'll have to do is search out my name, Adnan Rahman, and I'll be happy to connect with you. Okay. Now, how to find out if a website allows web scraping? That is actually a very good question. Now, if you think about it, every website or every piece of data on a website is actually that company's information or that company's property. And for the most part, people are not really happy that you're taking their data for free. So they would usually put safeguards in place, right? So for example, if you tried scraping LinkedIn or Indeed or AutoTrader or whatever, even yfinance actually, if you tried like scraping too fast, they will definitely block you, right? Just because they don't want you to, first of all, overload their servers, and also they don't want you to have the data for free. So the best bet is to try scraping it. If you run into any issues, then try a different way. Try looking up on Stack Overflow, try looking up on Reddit. All these different community sites are great for, how should I say this in a decent way? Basically having a certain disregard for rules. So Reddit and Stack Overflow are usually great places to find out if you can do something that you're not allowed to do on web scraping, okay? Amazon does not allow people to scrape it, exactly. So even Best Buy and all these things, they would definitely make it super hard for you to do so, right? There are definitely ways to do it, but if you are looking for some sort of commercial viability from it, it's going to be super hard for you to do so. That's what I've found out, okay? All right, so I will hang around for the next 10 minutes if you guys have any questions. If you don't, then I wish everyone a great evening ahead. Feel free to join in the next events. You can always join us on the Meetup group if you haven't already, and we'll always keep constantly updating the events over there, okay?
I have a question.
Yeah.
So currently I'm actually finishing up my final year of computer engineering, and I'm not sure if I would be like working in May because I'm still applying for jobs, or if I would not have work in May. And I'm actually interested in the data science bootcamp, so I'm a little bit unsure should I apply for the full-time or the part-time, because if I'm working full-time, I'm not sure if the bootcamp is the bootcamp for data science like online, or is it like in person?
So all of our classes are online. It'll be held over Zoom. And as far as the timing is concerned, if you have a full-time job, then part-time one would definitely be viable, just because that one is exactly like, it's specifically designed for people who have jobs and they cannot devote the full time to the program.
But the application we are supposed to apply like right now, but for the bootcamp. But the thing is, I'm not sure if I have a job in May or not, so I'm a bit confused.
Okay, let's say that I'm not too sure about when the data science bootcamp starts, but let's say that you have applied for like the part-time now, and you can always discuss it with our operations team about the starting date for the data science full-time course. And if you see that by May that you're not able to land a job, unfortunately, you can always switch to the data science full-time course if the start time starts then.
All right. And because I heard that in the part-time, we don't get to do client projects, but in full-time, we do get to do client projects. And I actually wanted like a real world experience with data science. So
I totally understand. So there's two things, right? So for the projects itself in each of the boot camps, all our projects are built to replicate real-time use cases, right? So things either that our instructors have faced in the past, or maybe projects that the students have gotten for interviews, right? So these are all full end-to-end use cases. If you're looking for a client reference project, like for example, something that you can refer to in your resume, then definitely that would be a point to consider when you're applying for full-time or part-time. I am not too sure about the details of whether you'll be able to access access the client projects with full-time or part-time for data science. So what I would recommend is to reach out to our program advisor team and just send them a message, give them a call, and just ask them about the details, and they'll be able to give you details about that, okay?
Okay, all right. Thank you so much.
No problem.
And thank you so much for this workshop.
My pleasure.
Yeah.
Okay, what package can I use for scraping non-tabular data, like a paragraph of text? Yes, exactly, Michael. So there are different packages out there that allow you to scrape text itself. Beautiful Soup is there. Selenium is, well, Selenium is a web driver. It's not a web scraper, but you'd be probably using a combination of Beautiful Soup and Selenium. No problem. I think even Pandas has a text web scraper. No, yeah, it looks like it doesn't. But if you're looking for non-structured data, then XML, like read_XML, is always an option. Will we get the link to the notebook? Yes, I think you disconnected as I sent the link. So let me resend the link here. There you go. So you should be able to get a copy on this on your notebook. Okay. All right, so if no more questions, we can call it a night. Again, thank you, everyone, and I look forward to talking to you all in the next session. Take care.